Good afternoon, good morning, good evening. Welcome to EIG's 43rd unique webinar, Practical AI Fireside Chat. We appreciate that you are taking your time to attend Enhance International Group's webinar series on building evolving resilient enterprise, especially in light of the continuous coronavirus pandemic. We hope that your family are healthy and safe. This is our 5th webinar in our Practical AI for Business webinar series. We started off focusing on OCR, then we went into image to insight, projection of the real world with a case study, and then the third webinar was focused on video to insight, looking at the visual and audio worlds. And then our last webinar was looking at video insight for safety. So today, we thought we would wrap it up with a fireside chat on what are the problems that can be addressed with practical AI approaches. We look forward for an interactive webinar consisting of some polling questions as the one you see here on the screen. And so please have your cell phones handy and or open up another screen in pollev.com/Jim DeVries 073 and answer the polling question. Again, my name is Jim DeVries, president of Enhance International Group. EIG is a platform of 50 plus consultants, consulting companies, and SaaS providers dedicated to empowering your organization's workforce to expand and sustain your organization. Our goal is to provide collective, collaborative, experienced thought leadership to enable organizations to deliver self-sustaining, positive margin growth, the competitive advantage. We thrive at delivering 1 + 1 + 1 = infinities. We hope you find this information useful. We will be sending out the slides, and the video will be available on the EIG website by the weekend. Again, we're organized by people, process, data, and technology. Today, we're talking about technology with AI. Our next webinar will be on digital twins on October 5th, and we'll be continuing our series in new product introduction, supply chain risk management, and some other topics coming up in October. So we look forward to seeing you there. Today, we are fortunate to have with us some highly respected leaders, Dr. Bulent Unukur and C. Bonovich. So Dr. Unukur, you want to provide an introduction, please?
Thank you very much, Jim. Thank you. Good morning, good afternoon, and good evening to everyone. Thank you very much, Jim and C, making this event possible. And mostly, thank you to all participants, as this whole entire event would have gone to waste if you would not have shown up. So I am the founder of Data Speckle in British Columbia. We focus on complex imaging, data science, and AI problems, and specifically implementing computer vision algorithms for healthcare, aviation, autonomous vehicles, and in the financial sector. I'm a physicist as background. I have developed data reduction, automation, and image processing algorithms at almost any wavelength for the state-of-the-art imaging and signal processing instruments, radio telescopes, X-ray and infrared satellites, and medical imaging. I also led technical groups and scientists at international level, established research labs, taught physics, medical imaging, computer science, even cosmology courses at Max Planck Institute, Herzberg Institute, and at the University of British Columbia. I hope this event would be as entertaining for you as it is for us. Thank you very much for participating.
Thank you, Bulent. I'm C. Bonovich. I also go by Carol. I tell people in this century I'm C, but in the last century I was Carol. But when the new century arrived, I thought, I should have a new name. I'm with Fuse Machines. Fuse Machines is an AI talent consulting and education company with a social mission to democratize AI. I've been with Fuse about 6 years, and prior to joining Fuse, I had a career in finance. Recently, I've been focused on finding educational partners in the US to teach AI because that is part of our social mission. Jim, I guess we should go to the next slide.
Yeah.
just to repeat, this is the 5th in a series of AI webinars. We began with, let's call it the basics in digital transformation, because one of the first things you do when you start on this journey is to understand what OCR is and to use it. Okay, so I mean, that's step one. Then we taught people a little bit about how to use computer vision in our Image to Insight webinar. And then in webinar 3, once again, we talked about video. And we did that again in video in webinar 4. Today, we hope that we are going to get questions on practical applications of AI. And there will be a webinar 6, and we will announce the date. It will be another fireside chat, and it will come this fall. Next slide.
Thanks, C. So we thought we'd start with a little bit of humor, and wondering if any of you have ever felt like you're stuck in the Stone Age, if you can relate to these guys. Round or square is defined as good in the eye of the beholder, right? The guy pulling, they're thinking the square is good. And obviously the guy with the round wheel says, hey, maybe a round wheel would work. So, so sometimes we get fixated in paradigms, right? And it's always done this way. And so today we're asking you to open up your minds to explore possibilities that may help us to move forward down the road, maybe a little faster. AI capabilities have, as we know, dramatically changed over the last couple of years. It's been crazy what's happened. And there's new opportunities that we could only imagine in the past that are now a reality. And we're really excited to get started, and C will take us through our agenda today.
So the way we think about practical AI is, number one, you've got to figure out what is the best approach to solve your problem. And then critical to any challenge is the data, right? Do we have the data, or can we create data? Because there is no AI without data. Then next, we're going to think about what kind of tech stack we need to implement. And following that, we also have to figure out the best algorithms for the challenge. And then we think through, once we've got all of this lined up, what practical applications make sense. At Fuse Machines, we've developed what we call the ADER scoping framework. And anytime we look at a business problem, we look at it through the lens of this framework. So number one, A stands for algorithm, right? Is this project feasible? Are there algorithms that have been created which lend themselves to solve this? And when you work with someone like Boulant, they'll off the bat tell you, well, you've got 6 algorithms listed there, but only 2 of them make sense for this kind of project. And in the end, probably we should try this one first. So you need somebody who's at the highest level of AI to help you figure out what algorithms should be used. And then typically we're customizing them. So we're often working with open source algorithms so that we can customize them to be right for this particular challenge. I stands for impact. You are unlikely to want to do an AI project that doesn't have huge impact because it takes time and money, and you want to make sure that what you're going to spend your time and money on will have significant positive impact to the business. So we look at what is the return on investment. And then D stands for data. And if I had to say what is the most important part of any AI challenge, it's the data. 80% of getting a good project completed is that you have adequate, proper data. And we'll talk more about data later. But as I say, when I look at this framework, And if I put percent on what the importance of each may be, data is either 70 to 80% of the success of your project. And then lastly, the R stands for recurrence. You typically want to do an AI project for something that recurs a lot, because you typically want to collect data continuously and apply that data to your model so that your model is continuously getting smarter. We'll discuss some of this later on in the webinar. Next slide. Oh, I think that's, yeah. So we now have a polling question. And what we're going to look for here is, what's your top challenge in deploying AI? A, not sure if the problem is applicable to AI. B, too expensive to solve with AI. Not sure of the return on investment. C, fear of losing control or security of the data. D, concern that there is not a way to economically collect the right data. E, none of the above. And if it is E, we hope that you'll put something in here. You can write something down in the chat window so that we understand what your challenges are.
All right. Interesting results. So very interesting results. Thank you for entering. It looks like we're kind of split between these three here. Not sure if there's a problem, too expensive, and concerned there's not a right way or a way to economically collect the right data. So see, I think you hit a spot on in the beginning. It's all about the data.
It's all about the data. Yep.
It's all about the data.
That's correct. This is usually what we observe actually in many of the projects that we're conducting. The first thing usually is the data, the availability of the data, and collecting the data. Sometimes collecting the data is so difficult. Sometimes people do not know what to collect, and sometimes it's expensive. But actually, there is a big hype on that as well, because this is a general thought. Sometimes there are some certain ways that we can remedy that problem by simply providing data, creating data, and sometimes most of the business owners don't think that they have the data. That's also another fact that we have been facing time to time. Data, however, no matter what it is the most important thing, and there are concerns on that. I think that's one of the most important things. The second one usually we come up with is the expense. So people think that it is too expensive. And today we probably are going to, or at least try to convince you that that must not be the case all the time. And there are certain ways to get over that.
Go ahead.
We have some questions.
Oh, great.
Okay, first
question. Good. That's what we wanted.
Yeah. How much data do I need to get started for an AI project? Can I get started with a small amount of data? That's
a very good one. Well, every project is different, right? Depending on the objective of the project, the data needs change. What we usually do is, however, look for the diminishing returns for every different project. If you would like to just draw a graph, it's just almost an exponential graph. If you like to draw the size of the data set with respect to the accuracy, or just vice versa, accuracy versus the data size, we always see an exponential function. And at some certain point, we figure that we need data, but at some certain point, no matter what you do, it's not going to help you. I'm not quite sure if I can annotate over here, but that's an interesting thing. We usually see, let me try to draw over this. So basically, this is what we have. Oh, I cannot annotate.
Boulant, there's another question that's belongs here. And the person is asking, do I need label data?
Yes and no again. Sometimes label data is of course very nice because for the supervised learning, this is what you want to have. And label data ensures that you can check the validity of your model, and that's a very good thing. Sometimes there are some models that you need to go for without labeled data. That's another thing. And the third option is semi-labeled data sets could be also used. And time to time, we also try to generate data from unlabeled data sets. We try to generate labeled data sets as well. So that is another option. So the answer to that is, if you have labeled data, that would be fantastic. But there's some problems simply can be solved without labeled data as well. And there is also a hybrid solutions to that one. You can generate labeled data, or you can synthesize and you can use synthetic data as well.
One person is asking, can you use data from different systems in your training set? In other words, can you combine different types of data like video or ERP or GoPro?
That's fantastic. Again, we have seen several examples of that one. So machine learning in the last 10 years, or even maybe before that, was just a standalone topic. We were just trying to come up with machine learning models, deep learning models in order to solve that problem. That could be object segmentation, object localization, or just trying to identify just classification and such. But today, there are so many different sources of data.
Right.
So speech comes and that is converted into text, and that is usually supported with video. Yes, the answer to that, the short answer is yes. There are so many different ways to do that, but I see that in the future, more and more, we are going to be gathering data from different channels and merging them, an amalgamation of all these sources of data will be the basis of the data sets, I believe, in the future. It's already the case, but many of the projects are ignoring them.
Yeah, and to your point, Will, and I think that's what's changed over the last 3 to 5 years, is that capability now to combine those different types of data sets more easily and economically than, say, 5 years ago.
Correct, because
Yes.
they are available now.
Yeah.
Well, and it's cheaper now. So some things have gotten more expensive and other things have gotten cheaper. So one of the things that has happened is, I would say, it's now more economical to collect data. There are new tools. It's just less expensive than it would have been a dozen years ago.
On the downside, the complexity of the algorithms has increased tremendously, and that is reflected in the speed of calculations. As you have more data and more complex models, that relies on more speed in the calculations, and that is actually making a very interesting thing for the downside. Do you have the fast, trusted platforms to process your data?
Yeah,
and I think that leads right into our next topic. So
sure.
Maybe we'll just go right into the next slide.
But keep your questions coming, and we'll keep answering them. Okay.
Absolutely.
Jim, I think this is you.
Yeah, this is me. So this is a classic slide that's been around for probably 25, 30 years now, believe it or not. And the level of analytics to make business decisions, it still holds true today. Do we just use experience, not data, to make our decisions, whether it's locally on the job or at an executive level? So generally, we make data based on our experience or how we've been taught. So everybody does that every day. And then the second level is we collect the data, but we just look at the numbers. Well, that's very often the case. Is you may, executives, or even if you're working on a production line, you look at the numbers. How many widgets did we make today? We made 1,000. Oh, okay. Is that good or bad? I don't know. Okay. So we're looking at the numbers, but it's in hindsight. So everything's in hindsight. This is what we did. And then you could turn those numbers into nice fancy charts and graphs. And so now you can see trends over week, shift over shift. And you say, oh, are we performing as we expected? And then we use census data where we get together and talk and use some more descriptive statistics, and then sample data where we are looking more into, taking actual data to make conclusions. And this is actually using statistics. This is the first time we probably will be really using statistics that's meaningful. But often when you're at that stage, the data doesn't represent the process. So moving from step 5 to 6, where you're going to inferential statistics and inferring something, takes some belief in the data. So just as we're talking about an AI application, as we've been talking about, we want to be able to get to stage 5 or 6 with the data that's there, and everybody is trusting that data so that we can predict things and get to stage 7. So in real time, using neural networks, a digital twin, and so forth, we're able to move into step 7 and 8. It used to be, I feel like I'm an old man now, but it used to be a 2 or 5 year journey to move through here. What's changed is you can now do this, move from step 1 to step 8 in a very, very short period of time, in a matter of months.
Right.
And that's what's changed. And so don't get too hung up on it, because there's always more data out there that we can get. And in our capabilities, the technology capabilities has changed dramatically. It still requires you to have good, clean data and believable data, which is always the second question once you have data is it clean? Do you believe it? And what are you going to infer from it? But that's an iterative process, but it can be done in an accelerated fashion. So any questions on that slide, or we move to
Let's see.
We can just move to the next slide.
Yeah.
Because this all goes together with this, your competitive advantage on the y-axis and your maturity of using that data on the x-axis. So, you have your raw data, clean data, you have standard reports, functional scaled. So this is all historical data, SQL databases, the way most companies operate, especially companies that were founded before 2000. Companies that are built after 2000, they built the infrastructure ahead of time so that they could quickly do predictive analytics, the things that we hear about what Amazon does, Starbucks does, all these companies that are using data in real time to make better and better decisions. And so that predictive version, and that's where we want to get to with an AI application in a company, is moving along in a specific area so that you can make that get to that cognitive decision real time. But there are very few companies that are doing cognitive decision making across the company. They may be doing it in pockets, but the majority of folks are moving, starting off, probably functionally scaled, maybe horizontally integrated, but not yet into that predictive. So you're not alone. If you're further along than that, then that goes into our next survey question, which asks, which area are you in? Descriptive, predictive, prescriptive, or cognitive decision making on the projects that you're working on. Any questions?
Yes, we do have a question from somebody who's concerned. How do you work on a project with outsiders and keep your data secure if your data is on-prem?
I think Boulant, you and I talked about this last night. Do you want to respond to that?
Data is on-prem. Yeah, okay. So there are certain things.
But you want to have people from the outside work on that data.
Yes.
You shared some technology with us last night.
Well, basically, there are several options that you can go. You want to share the data, and at the same time, you want to keep it really secure, you would like to go to cloud. That's the first step you automatically think. But cloud is totally out of your control. And most of the time, just speaking of the clients that we are having, they do have data that is very private, patient information, or just some information that companies do not want to release to their competitors at any cost and all that. Then cloud becomes easily not an option. There are several other things. For instance, the existing cloud platforms, whether it be Amazon or Azure or Google platforms, they are very enticing because you can start with them quite easily. They offer you free offerings and all that. You can simply launch your algorithms. In many of them, there are off-the-shelf algorithms pre-installed. That's very good. But when you start really working with the teams, you can simply hit a bottleneck in a very short time, because the resources are not really that much to start with. And if you like to increase them, that's some sort of a clickbait if you want to take it that way. Then you need to really increase the instances, increase the memory, and allocate more and more resources. That easily turns into a big swamp, so to say. One of the actually nicest way of tackle with that is to use dedicated or hybrid servers. They can be quite secure, HIPAA compliant, and at the same time, you can work with the teams together. We have seen so many different projects, and in many of them, we have applied those dedicated servers or hybrid servers, and we have had really good results with them in terms of security, GDPR compliancy, as well as HIPAA. So my suggestion in that is just to check and find the easiest, cheapest solutions. Most of the time, dedicated servers people are really afraid of can be a lot cheaper, a lot faster, a lot more secure. I hope that answers the question.
Yeah, thank you, Bulent.
Great. Any other questions that come up while we're looking at the results?
Let me check.
While you're doing that, I mean, the results here are
we have an interesting question, which is not related to this query, but who is responsible if an AI algorithm fails? For example, what if a surgical robot makes a mistake? Speaking of healthcare.
That's a very tough one. And actually, this brings us to the discussion that we have had several times during these past webinars as well. The ethical concerns and the lack of regulations in these fields. Yeah. So as we don't have any such regulations or commonly adopted regulations, currently it's very difficult to answer these questions. But most of the time, these algorithms are tested very well, and especially when a human life is a concern, then these algorithms are really tested billions of times, retested, checked, and all that. This does not mean that they're not going to make any mistakes. The question is very open. I do not have a ready answer for that one. I think it just depends on the regulations, because in some countries or some regions of the world, one thing may be considered a responsibility, whereas in the other one, it may not. This actually points out the need and an urgent need for regulating the AI and AI algorithms, and together with the ethics of AI. That's a fantastic question, but I do not have a ready answer. I hope much of information.
There's no simple answer, but I can tell you when we are doing algorithms or doing projects for healthcare facilities, when it relates to patient care, that is something that they spend a lot of time, and they're willing to put a lot of effort and energy and, of course, money to get to the kind of results where you would not expect many mistakes, meaning they're aiming for what I call 99+% results.
To support that,
is that 99.99966%?
Yeah. I mean, we can never say never, but people are spending a lot of time and effort. And typically, if you're talking about surgery, next to the robot is a real person.
Yeah.
So they do have the robot doing many tasks, but it's not like it's all robot surgery. I don't know any place in the world that is doing robot only surgery. Do you, Jim?
No, I don't. I think you're spot on. And
I think it's
not that I know.
robot supporting roles.
But if we look at in the aviation sector, as well as predictive oncology or diagnostic in oncology, for instance, the accuracy is surpassing the human capability already. So where a robot is making a mistake, a human would most likely make a mistake too.
Yeah, that's a good point.
Yeah, the autonomous vehicles is a great example of where, you know, they're putting in these trucks that are going across country. Whether you know it or not, in the United States, there are autonomous trucks crossing the country as we speak. And they've been doing it for quite a while. But there's still a driver in there.
Exactly. But there's still a driver in the cab. Yeah. Somebody asked, and this relates to what we're just talking about. Okay, can we trust that AI make critical decisions? And
it's a hard question as well, but the answer to that is AI is not context aware. We need to really figure that. The semantic gap of AI, that's what we call, when we see an image, we have all these connotations. Let's say I look at your video, and I see a lot of things about you, which is not reflected on these individual pixels. But an AI algorithm barely and merely sees those individual pixels, convert them into numbers. That semantic gap is actually a big hindrance for the AI. And at the same time, that brings us to question to the ethics. So ethics is not or should not be reflected on the AI itself. It should be reflected on the people, on the brains behind the AI. So AI is as ethical as you are.
Well, somebody asked, what framework are we using to address ethics, AI ethics, obviously? And how are we addressing this? Well, I will tell you that sometimes people come to us with a project and we turn it down if we don't think it's ethical. I mean, people have come to us with projects that we wouldn't take on.
That's correct. That's correct. And especially if your source of information is not reliable and truthful, you may easily inadvertently end up into pitfalls of AI, as has been demonstrated recently in several research papers on GPT cases. And we have seen some examples of GPT just making really, or just drawing really weird conclusions from the information that they gather. But based on the information that they have, it's just simply picked up from the internet. Basically, it's just replicating the human behavior and superstitions and everything. So we have to be really careful about the source of the data.
And we sometimes are very fortunate, and we are working with some organizations that are trying to do AI for social good. And we work on projects like to prevent human trafficking, right? So we've gotten some really socially responsible projects, which we're thrilled to work on. So, and as a company, we just turn down projects if we think that they don't fit into our company's ethical standards.
It's a great discussion on AI ethics. So I think maybe we'll move on to getting back to the technology stack, if that's okay.
Yeah.
And the famous hype cycle from Gartner. There's hype cycles for many things, and of course, AI is being one of the top ones. And just to review what a hype cycle is, it's just what it says. It's hype. So you got the first one. Everything's in hype. So what's hot today may be not hot tomorrow. So on, you got your innovation trigger. So everybody comes up with things. These probably proven things that people have seen that works and is working in pockets, but hasn't really fermented to go over the hump, so to speak, where now people are, when it's over the hump into the trough of disillusionment. Well, what does that mean? Well, that means that now people believe that it's going to work and it's going to solve everything. So then they apply this to everything, deep learning, augmented DSML. So we overindulge in it. Overpromise. And then we get to reality as we come out of the trough of disillusionment, and then we get to the slope of enlightenment. And then you see these true and tried things, like we talked about predictive analytics earlier. That's been around. There's nobody's going to question that.
Right. People are comfortable with that.
Text analytics, we talked about that in our first webinar. It's been around for a while. DBMS analytics, these things are all, and event streaming processing, these things have been all tried and true. These are probably the things that if you're starting, haven't done these, you would want to start on these things on the right. You don't want to be trying to do adaptive machine learning to start your first project, unless there's a compelling reason to do so. But, the deep learning, there's still opportunity there. And of course, graph analytics, you can't go wrong with, but it's still maturing. So this is a really good way to, when you are looking at your applications, is just putting everything in perspective of what you should be focusing on. And you should have a coach to help you with that, as Dr. Unaker is, to help you find what is that right tool, the right thing to promise that's going to give you your return on investment.
It's very interesting to see this curve, actually. As we talked, this looks like a camel or a squirrel. And it's very nice to see data science education, sadly, is climbing, is probably at the peak of inflated expectations. We want to see data science education on the other side of the hump. Correct. Because this is going to be very crucial for next generations. Without data science education, it will be very difficult to generate the workforce to start with, and obviously the users. And it's very encouraging to see the other technologies like deep learning and advanced image video analytics. They are at the stage, or just very close to the stage of disillusionment. And that's actually a very good sign, because as things go this way, the number of data sources are increasing, computing power is just getting faster and faster and increasing. And at the same time, our understanding of AI is improving. This means that we're going to be seeing more and more established algorithms and applications are going to emerge in time. And hopefully we're going to be able to see them at the region that we call slope of alignment, where it is settled. But having something on this region does not guarantee that everything is done at that stage is very well established and all problems are solved. As we gave examples of GPT, like it's one of the prime examples of text analytics over here. I can just read some codes from GPT. GPT is asked to answer a question: can coughing effectively stop a heart attack? And with 175 billion true reference answers and sources, the GPT came up with the answer: coughing can help stop a heart attack. And there's so many interesting things. GPT is telling you the US government caused 9/11, or when it just comes to the temperature, the weather outside. If it is cold outside, what does that tell us about global warming? When this is asked to GPT-3, it tells us that global warming is a hoax. So we have to be very, very careful our data source. Again, no matter where you are on this curve.
That's all right.
That's a
So,
good point.
and we're still in the point source application. When we try to use things that are outside of a point source and we expand, again, models are only as good as the model and its boundaries as you set it up. When you go outside the boundaries of your model, you're going to end up making incorrect conclusions. So we always like to stretch things because we want to see how far it can go. And then when it comes back and doesn't tell us what we expect. So when something is designed, it's important to say, what are the constraints? What are the boundaries? So after you get the data, it's very, very important to set up your boundaries for the problem that you're solving and make sure that within those boundaries, you can be confident that a good decision is going to be made with your AI algorithm that you're creating. That's also something that sometimes is overlooked and not discussed enough. Your thoughts, Bullant?
I agree with that. It's just basically I go back to my original expression. AI is as ethical as you are. At the same time, AI is as smart as you are. So whatever the information that you're feeding into the AI, this is what we should be expecting to get out of it. Basically, we should not really forget the definition of AI, because AI on the whole is a tool, a system of tools that are put together to mimic human behavior and human thinking. So if it is thinking like a human, it is quite understandable that it can make mistakes like human.
Yeah.
We do have a question. I think we can briefly answer it because we talked about it before. Can you meld data together from different systems?
Oh, that's
Which
key.
you can.
Yes, that's absolutely critical that we're able to link data from different systems. And that's one of the things we discussed earlier that's really changed. And
how easy that is. Yeah.
How easy it is. I mean, it used to be, even if you take like continuous data, like in a plant and how it runs, like a chemical plant, and then you have discrete events of maintenance or things that happen discretely, activity-based and continuous data, we can now meld those two worlds together, which, 5, 10, even 3 years ago was very tough. But now we can do things like that. So we're able to bring in all different sources of data much easier than we've had in the past.
Much more efficiently, I'd say, is the right way.
I'm sorry, go ahead, Steve.
Much more efficiently.
Much more efficiently. And, again, we talked about segmenting the data and parsing the data and tagging the data. All those things, the better you do that, the easier it is to link these things together. But,
in addition to that, actually, it's not only the ability to meld or data together, it's actually the necessity of that as well. Because as the sources of information increase, we have to use audio data, we have to use video data, and we have to complement that with text data, because all these are the ingredients of proper projects or communication. Just consider yourself just watching a movie. It's not only just text. Yes, you have subtitles, but you are just seeing people moving around. It's not only the imaging. You do see the audio, and all that information we put all together to work that human intelligence to work. And as we said, if we are going to be mimicking the human intelligence, we need to get all that information that humans are getting, and we need to harvest them, all of them. So it's not only the ability, I think it's a necessity. We have to put all these things together, all sources of information together to derive meaningful decisions, making sense of the available data. Because if we have access only one part of the data, it may be useful and enough for some certain projects, but as the projects are getting more and more complex, it will become inadequate. It will become incomplete to derive any conclusions from the limited amount of data.
So I think this leads us into the next slide here.
Yes.
It's yours.
We have talked about this tree structured two-column slide. I think we went over that in the last webinars as well. On the right-hand side, we do see the basic subtopics of AI, so to say. We have machine learning, deep learning. By the way, this is not a complete list of the topics that are available in AI, but these are merely the compilation of the topics that we usually come across when we talk with our clients in the industry. So these are the needs of people and the respective topics that we come across. Most of the time, we do see need in machine learning, deep learning. When it comes to on the left-hand side, we can see regression or classification. And again, these are not really strictly binded with only machine learning. Well, we do have classification and regression in deep learning as well. We do have regression and classification in natural language processing and so on. So these are just complex topics that can be complementing each other depending on the needs of the project. On the right-hand side, we do see natural language processing, for instance, that is tied together with translation, clarification, clustering, information extraction. It could be from health documents, it could be personal information, it could be financial information. And that is also, again, tied with speech, natural language understanding, and natural language generation. And all these things can be used in some certain parts of the project. Those are the things that we do usually see. And expert systems, although they are very old way of statistical machine learning examples, we do see that they are very powerful. They have been used in space research, in decision-making algorithms, and in many other places. When we come to the last one, we do have the computer vision. Obviously, computer vision goes along with image recognition, machine vision, and there's a lot of algorithms that we do with computer vision, especially with the advance of computing power. I have a little list over here. What can we do with computer vision and what are the hot topics actually in computer vision? Computer vision applications in retail and e-commerce, for instance, auto checkouts and all these kind of things, digital shopping experience. These are really hot nowadays. The second topic you usually come across is computer vision applications in education. Then afterwards, healthcare. There's so many different things that can be automated using computer vision and deep learning algorithms. Interestingly, we do see fitness and sports applications very much in trend nowadays using deep learning algorithms. Then, of course, we do have manufacturing and mining industry comes. Then we do have cross-industry applications. So many of them are just making life a lot easier and better and using these new computer vision augmented with deep learning and machine learning algorithms. Next slide, please. Let's just go on to the next one and continue our discussion.
We do have some more questions, so let me know.
Well, why don't we do the poll, and then we can take the questions while we're doing the poll.
Okay.
Okay. So one person is asking, how do we address cybersecurity concerns in AI applications?
Cybersecurity is a very well studied topic, and it's very hot as well. There's so many different things, and I'm sure you have heard all these security measures, and at the same time, the blockchain applications that can help preventing fraud or the data leakage and strong encryption algorithms. So encryption together with blockchain are very well studied and currently hot trending topics of AI used as weapons, so to say, to prevent fraud and to provide security for the applications. And obviously, we do need some server security on many sides as well. That is being usually done with dedicated service most of the time.
And another person is asking about determining the cost of a project. And we've had several questions. This person is asking specifically, how do you think about people versus computing cost? And
Mhm.
how do you avoid access? Well, I think maybe we should just spend a little bit of time talking about the cost of projects and human versus computing power.
Let me start with the human versus computing power first. Using human is a fantastic idea. We have done this in the last probably couple of 100 years, and it's worked out quite well. Because human brain is very skillful in determining the patterns, in figuring out and sensing using the context and all that. But the problem with that is when the data points increase, we are incapable of tackling with them. And in the short run, it may seem that using human power is economical, or it's a lot easier and such. But in the long run, actually, it is not, because you have to train these people. That's the first thing. And these tasks usually are very repetitive, and people can only do these tasks for some certain time periods, and then you start losing these people, and the quality degrades enormously. And the other thing is you cannot replicate if something happens, and you cannot simply redo the things again, because if you want to redo those, then you need to spend the same amount of time and effort for those. So in that respect, using human power in this digital world is something, a concept that belongs to the last century. I don't think that there is any place now to use human power when AI can do it for you.
Right. But the fact is, in designing a project, you are going to have the cost of running your project, but also you need to have engineers who are going to figure out which algorithms to use and put it all together for you, right? So there are two pieces to the cost.
Yes.
And then there's the ongoing expense, obviously, as you continue to collect more data and you continuously run your models.
That is correct. So that simply using AI requires skillful workforce. And that's a good thing, though, because that increases the education of the people that you require, that can ask questions, because instead of people doing repetitive work, now you have a workforce that can ask questions that can enhance your projects. Yes, at the same time, it's difficult because you need to educate them, but this is how societies evolve. And if the question is whether we want to have a society that is highly educated or not. And I don't think that there's any choice in that, in this world, in this digitized world and economy anymore. So that is a logical way to go with that. And yes, you need dedicated people, you need educated engineers, you need to generate more and more data scientists. And basically, data scientist is just a misnomer. I think you need to generate more and more scientists. That's probably the prime thing. But at the end, you need to increase the education level of the society in any area possible. And that's why when I just saw that Gartner curve, it was so intriguing to see that data science education is on one side of the hump, and probably it is going to settle sometime and it becomes the norm.
I would also add, on a practical level, if you go back 30 years, because AI was used by the Fortune 50 30 years ago.
Sure.
Probably starting in the 80s, the Fortune 50 were using it, but they were spending a minimum of $500,000 and usually $1 million or more to solve anything. So what that expense is, probably it's 20% or less today to solve the same problem, because the computing power has reduced in cost so much, and people can do a lot more and learn how to use the tools very efficiently. So you can probably get a proof of concept done, depending upon how sophisticated you want the proof of concept to be, for 50 to 100,000. And that problem probably costs you at least 500,000 if you go back to the 90s.
That's correct. That's correct. And at the same time, we did not have access to the talent in those times. And even 5 years or 10 years ago, it was not possible to have access to these talents as well. One solution to that is actually not using the whole data science team or an AI team altogether, because they are very expensive. Sometimes it's very difficult and maybe not feasible to have the whole data science team in-house. But you can actually look for help from outside, and there are so many different solutions that they can help you for a fraction of the cost of the project. And that talent and cost problem can be solved by leveraging that.
So I'm going to interrupt here. I just want to thank everyone for answering the poll. I think it's very interesting where it ends up. It's fairly logical that, where you have lots of repetitive occurrences, the forest part of AR that's where you're getting the best applications. And of course, supply chain now being a word that 3 years ago, very few people understood, and it's a hot topic. I think in the past, you probably had customer call centers higher in this ranking. And it's interesting that, AI is generally quite often used in the transactional area versus the manufacturing, except in spot areas like vision for blemishes and things like that. And then we had our last webinar on safety and security, and that's probably an up and growing area because of GoPros and our ability to mesh the data together. So this list makes a lot of sense from what we've been seeing in the industry. So thank you for participating in the poll. Appreciate it.
Yeah, this is very interesting. I'm just taking a screenshot of this one because this reflects actually what's happening, and the majority of our clients thinking the same way. Streamlining the repetitive things, especially in the financial sector, revenue generation, and then supply chain. I think if you are not really, especially in those high demand computer vision, deep learning space, then these are the fields that benefit from AI mostly.
Yeah, we're at the top of the hour. We're going to just cover one more concept because it's our exciting slide. We left it for last. If you have to drop off, we understand. And thank you for joining us. We'll again have this recording available to you. And as Bülent will explain this, our tree that we created a while back, this is a pretty exciting area. So Bülent?
This is a nice summary of all what we have talked. If we can consider AI as a tree, we can see the main applications that we see, or the areas that we can see on that trunk. Basically, the encryption, blockchain algorithms, conversational AI, digital marketing, that's probably powering the whole internet. And obviously, autonomous vehicles, they don't have to be cars. They can be autonomous airplanes, autonomous trains, autonomous ships, and autonomous robots that are just working for us. So that's all under the same umbrella. Basically, we have the digital marketing, we have the expression of information in different ways. Conversational AI does not have to be only text, and we have the security of all the data. So this is actually the trunk of the whole AI that's powering the whole thing over here. When we look at these branches, we do see different colored apples over here. It's very nice to color them in different colors and try to group them as much as possible. But this does not mean that red apple cannot be mixed with green apple and so on, because most of the time there's a combination of these branches are deployed as AI algorithms or projects. Starting from the lower left and just going in clockwise direction, we do see semi-supervised learning. So this means that we do have some labeled data and some unlabeled data, and we simply extract some information from the labeled data. We assign labels to unlabeled data, and we don't really fully supervise the whole algorithms. We do see over here a lot of applications that is related with customer segmentation, speech analysis, targeted marketing, and website classification. For instance, face recognition interestingly falls in that area. So all these algorithms can be used for these sectors. When we go for basically the other main branch, unsupervised learning, that there you don't usually have labeled data. And we just rely on clustering the similarity of the data, the features, the attributes of the data, products, or whatever comes into the algorithm. And based on those similarity, we try to put them all in same groups. In this area, we do see applications like customer segmentation and target marketing, recommender systems, again, here in that area. Obviously, time to time, data is overwhelming and it's not possible to extract or absorb all that information. Then we need to go for smaller versions, smaller representative versions of the data without losing its meaning. And here we have the dimensionality reduction algorithms come into play. We try to go for compression, anything that is related with structural discovery or visualization that goes into the branch of dimensionality reduction under unsupervised learning, or just a neighboring topic to the clustering. When we go for supervised learning, here we do have labeled data. And when we have labeled data, again, we do see classification in other areas, but we do see the main applications of classification under the branch of supervised learning. Here we have, again, customer retention. So as you see, we are just repeating ourselves because customer retention or segmentation can be placed in different branches. You can get information from the other branches as your data suggests. And here under this classification branch, we do see fraud detection, diagnostics of imaging, especially that goes for manufacturing and health sector, and image classification. And as we see, image classification is an endless topic because we do have image localization, image classification, object detection, object tracking, scene understanding. So these are all under this branch here, classification. Then obviously we do have regression. Regression, basically, when we plot two variables with respect to each other on X and Y axis, and when we try to understand the dependency between the two, there we go enter into the realm of regression. So when we talk about regression algorithms, we do see market forecasting, weather forecasting that requires a little bit domain expertise at the same time. So we do see population growth prediction, advertising, and estimating of anything. So all these algorithms are used for machine learning and AI algorithms under the branch of regression. Then obviously we go for a different way of representing the data. So that brings us to the reinforcement learning. In that reinforcement learning, the idea is how to train a dog. You simply apply a rewarding mechanism and you apply the algorithm. Obviously, you're not going to be throwing bones to the machines. Basically, you simply reward the machines by giving them +1s and -1s and so on. But reinforcement learning is without having a model, you're trying to teach the algorithm by experience, so to say, in simple words. And here under this branch, we do see real-time decision-making and learning a task that has not been presented to the algorithm before, or acquiring a certain skill that the algorithm does not know before, and obviously navigation and gaming. Then afterwards, we come to a very interesting topic at the lower end on the right-hand side, which is the anomaly detection. Because if things go well, and if there is something, if you have outliers within the data, if something unexpected is happening, that is usually what we call anomaly. And we go for credit fraud detection, cyber intrusion, or anything unusual in the observed data, visual, textual, or audio. These are just the anomaly detection. So these are obviously put together, and there can be some different changes, but in general, these are the topics that we come across in the industrial problems or projects that we carry out day by day.
Great, thanks, Bulat. See, are there any questions coming in?
No.
Okay, so I have a question for the AI infused machines platform. Is that reinforcement learning then that we're using there to help on that platform?
Oh, in Fused Classroom?
Yeah, Fused Classroom.
Well, there are different modules. And so it depends on the module. It's not all reinforcement learning, but we have a plagiarism module. I'm trying to think. That's using computer vision. I'd have to go through each of the modules because there's a different form of AI depending upon what module we're talking about.
The platform itself uses all these reinforcement model or just classification mostly.
Yes,
when you classify the images and anomaly detection, basically, because if you're trying to monitor like proctored exams, then you see that some people are just doing anomalous things. They should not be leaving their seats or whatever, or they should not be talking to anyone. All these kind of things are just under these trees. But as topics in Fuse AI classes, we do teach all of these topics.
Right.
Right.
Well, I think we're getting close to the end here, or past the end. So I want to thank everyone. I'm going to do some close up. I just want to show one slide real quick that will be included in the packet. We won't spend a lot of time on it, but we did develop the 3 pillars, and we talked about visibility a bit today, the algorithms a bit, and the artificial intelligence. So if you move from bottom left to top right, you can kind of look at this as a maturity level kind of a deal, where as you're trying to build your overall AI ecosystem for yourself and your company, these are the types of things that you should be talking about and trying to introduce into your company at the pace that you can manage. So we just want to show you that slide. We could spend an hour on this slide alone, but just wanted to throw that in the pack. That's your bonus pack for staying late. So thank you again, everyone. If we don't have any more questions, I'm just going to wrap it up here real quick and just thank you. Again, EIG is a platform of 50 consultants and SaaS providers. And of course, we're talking about the technology area. In our next webinars, we'll be talking about digital twins, new product introduction, de-risking. And this is our team of over 50 companies. And again, we thank you very much. Boulat, do you have any closing remarks?
Thank you very much for everyone for their patience and attending and showing up and listening and asking questions. See you next time.
Yes, thank you for asking such great questions. That's what makes the webinar fun.
Yes,
and,
thank you so much.
We will let you know when webinar 6, the next in our series, will take place.
Great. Thanks. Have a great day, evening.
Right, wherever you are.
Wherever you are. God bless. Right. Bye-bye.